Hello everyone, welcome you all. In this video, we are going to learn chapter 1 real numbers of class 10th. Okay, so let's start with the concept of real numbers. Before starting with real numbers, let us see the number systems which you have studied or a student of class 10th has already studied up to class 9th. Okay, so actually, real numbers comprises of two types of numbers. Okay, real numbers, one is rational numbers, and another is irrational numbers. Now in rational numbers means, if we need to define rational numbers, then we can define it that a number which can be represented in the form of p upon q, where p and q are integers. Each and every word of this definition is important, and q is not equals 0. Okay, this is definition of rational numbers. And if we need to define irrational numbers, then simply irrational numbers are just those which are not rational numbers. Means in the world of real numbers, if we have to say about irrational numbers, then simply on the basis of the definition of rational numbers, we can define irrational numbers. You have to simply add a number which can't. Okay, here we have written can, and in irrational numbers we can't. Okay, so what will be the definition? A number which cannot or can't be expressed can't be expressed in the form of p upon q, where p and q are integers and q is not equals 0. Okay, so here you can see the definition of both rationals and irrationals are likely. Okay, a rational number which can be represented or expressed, and irrational numbers which cannot be represented or expressed, okay, in the form of p by q. Now let us understand these definitions. Here for rational numbers, we have written in which a number which can be expressed in the form of p by q. Okay, for example, if we are taking 2 upon 3, okay, then you can see here that 2 and 3 both are integers. Okay, so it's a rational number. Another example, like if I'm writing minus 5 upon 7, then again minus 5 and 7 both are integers, so this one is also a rational number. But if I write like 5 upon 0, then this is not a rational number, even it is not any number. Okay, because division by 0 is मीनिंगलेस. कोई मीनिंग नहीं निकलता. यू कैन डिवाइड एनी नंबर बाय जीरो. ओके, सो डिवीजन बाय जीरो मीन्स देर इज नो नंबर लाइक दिस. ओके, नाउ if I write in example only, if we write root square root of 2 upon 0, or let us take upon 9. Okay, then this is again not a rational number, because 9 is integer but root 2 is not an integer. Okay, root 2 is not an integer, so it is not a rational number. Okay, now let us move ahead with irrational numbers. Example of irrational numbers is root 2, root 3, root 5, root 6, root 7, etc. Okay, and other than this we have numbers like 0.100, 1000, 10000, 0000001. Means you can see here that number of zeros are increasing again and again. Okay, that means this number is non-terminating, non-repeating. I'll explain it in a while. थोड़ी देर में मैं इसको explain करूँगा. So all these are irrational numbers. Now what is the specific about these numbers? ये numbers किस तरह के हैं, ये irrational क्यों हो रहे हैं, ठीक है, why they comes under irrational numbers. और यहाँ पे अगर आप ध्यान दोगे तो I haven't included root 4. root 4 को मैंने include नहीं किया है. क्यों नहीं include किया है? Because root 4 becomes 2 as 4 is a perfect square, so square root of 4 becomes 2. Okay, and this 2 can be written as 2 upon 1, so it becomes rational. ये क्या हो जाता है? Rational हो जाता है. Okay, so root 4 is not included, but root 2, root 3 means square root of non-perfect squares will always be irrational numbers. Okay, so let's move ahead and understand. If we'll try to find square root of 2 using calculator or computers, then you will see that the decimal representation will not get any end. वो चलता ही जाएगा. Okay, अब इसमें थोड़ा सा डेसिमल रिप्रेजेंटेशन पे बात कर लेते हैं हम, क्योंकि एक नंबर यहाँ पे मैंने लिया था ये 0.10010000. तो ये क्या चीज़ है? नॉन टर्मिनेटिंग, नॉन रिपीटिंग. इसको मैं थोड़ा सा एक्सप्लेन कर देता हूँ, क्योंकि हो सकता है कुछ आप में से कुछ को इसमें थोड़ी सा डाउट हो. तो लेट्स सी डेसिमल रिप्रेजेंटेशंस कितने तरह के होते हैं. Decimal representations. So broadly, if we classify, then this decimal representations are of two types. One is terminating decimals, another is non-terminating. Okay, इनके examples देख लेते हैं. Terminating में like if we are writing 0.5, so decimal part में आपको देखना, you have to observe the decimal part. उसमें अगर finite number of digits हैं, that means कि हम जिसको count कर सकें, finite number of digits like 0.5, or you can say 2.342 or 0.159345 etc. यहाँ पे आप ध्यान से देखोगे तो पहले नंबर में सिर्फ एक डिजिट है डेसिमल पार्ट में, यहाँ पे 3 है, यहाँ पे 6 है, बट काउंटेबल है. ठीक है, एंडलेस नहीं है, एंड हो रहा है, मीन्स टर्मिनेट हो रहा है. टर्मिनेट मीन्स टू गेट एन एंड. So these are terminating decimal representation. Non-terminating. In non-terminating, again we have two types of decimal representations. One is non-terminating repeating. This type is also known as recurring. Reoccurring, बार बार जो repeat हो, बार बार आए, reoccurring, recurring. Okay, and another is non-terminating, non-repeating. अब ये क्या बोला है? This part is actually irrational, represents irrational numbers. So let us see examples of this. Examples से और clear हो जाएगा. Like if we have here 2.5 and there is means, and this 5 is repeating again and again. Okay, so we write it as 2.5 and bar over 5 decimal point. इसके ऊपर में एक point से भी denote करते हैं like this 2.5 and dot over 5. This means 5 will keep repeating, कभी end नहीं होगा. तो अगर end नहीं हो रहा that means non terminating. और since इस digit 5 repeat हो रहा है तो ये repeating हो गया, that means non terminating repeating. और example देखते हैं इसके like 3.237 237 237. That means 237 is repeating. This block of digits, यहाँ पे 3 digits हैं जो बार बार repeat हो रहे हैं. ठीक है, तो terminate भी नहीं हो रहा है that means non terminating, और repeat भी हो रहा है. So this is also an example of recurring. Okay, and these two, terminating and non terminating repeating, these two comes under rational numbers. ये rational numbers होते हैं because this 0.5 or 2.342 can be easily, you know how to, if you are in class 10, then you know that this can be very easily written in the form of p by q. Okay, like 0.5 can be written as 5 upon 10, and you can simplify 1 upon 2. It's a rational number. 2.342, this can be written as 2342 upon 1000. Okay, so this is also represented in the form of p by q. Definitely इसको और simplify कर सकते हैं हम, but you will be getting a form of p by q where p and q both are integers and definitely denominator is not 0, so rational number. These numbers can also be represented in the form of, can be represented in the form of p by q. Okay, so and this that one is a topic of class 9. So how to represent these numbers in the form of p by q, so I'm not going to explain here. It will be definitely will get explained in chapter 1 of class 9. Okay, you can refer to that video. Now, non-terminating, non-repeating examples of this. One example I have written already above earlier. Now see another examples, like if we have 1.21, then 211, then 2111, means you can see I'm simply increasing. Okay, I'm making a pattern, and in this if you'll see carefully that it's definitely non-terminating क्योंकि end नहीं हो रहा है. अदर थिंग, बार पुट नहीं कर सकते हम, यहाँ पे बार भी पुट नहीं कर सकते. अगर लाइक हो सकता है थोड़ा सा कंफ्यूजिंग हो कि यहाँ पे 1 पॉइंट कुछ लोग बोले कि भाई या आपको ऐसा फील हो रहा हो कि 2 और 1 रिपीट हो रहा है, तो अगर यहाँ पे बार आप पुट करोगे तो इसका मतलब होगा 1.21212121 लाइक दिस, एंड डेफिनेटली दीज टू आर नॉट सेम. ये दोनों सेम नहीं है. तो ये तुम्हारा हो गया, मीन्स सॉरी, ये आपका हो गया irrational number. Okay, and this one is rational. Okay, because this comes under non-terminating repeating. ये जो तुम्हारा हो गया मीन्स ये जो आपका हो गया ये हो गया non-terminating repeating. Okay, that means recurring, so rational. Okay, so this is the thing. Now you can definitely, means you can identify whether a given number is rational or irrational. Let us go with some examples. Like identify or identify following as rational or irrational. Okay, the first is like if we have simply written 16, so 16 can be represented as, this can be represented as 16 upon 1, so it's rational. Okay, then let we have under root 16, then this becomes 4, and 4 again can be written as 4 upon 1. So this one again rational, as it is, as it can be represented as p by q or in the form of p by q. Okay, let's say more examples, like if we have under root 17, Then since 17 is not a perfect square, so if you'll find the decimal, if you'll try to find perfect, sorry, square root of 17, then you will observe that you will be getting decimal representation as non-terminating, non-repeating, and in that case this becomes irrational. So we have not to do that that much. We have to simply see, we have to simply check whether if it is a under root square root, then whether the number is a perfect square or not. If it is non-perfect square, if it is non-perfect square, then it becomes irrational. Okay, otherwise rational. Okay, simple. Then if we have like square root of 2 to 5 upon 100, then 2 to 5 is a square of 15 and 100 is square of 10. It is represented, or if you simplify this, 3 upon 2. Even means I'm simply explaining here. You can write it directly as rational or irrational. Okay. So we have seen some examples. Let us see some more example like 0.25326, 25326, 25326. You will have to observe carefully कि क्या same digits repeat हो रहे हैं, या कोई बीच में मान लो एक भी digit अगर change हो गया, then ये तुम्हारा means this one will become irrational. Okay, but this time 25326, these digits are repeating and again, so it is non-terminating repeating, that means recurring. So this is an example of rational. This becomes rational. Let us see one more example. Like if we have 2.36, 336, 3336, 33336, and dots, that you can see that it's forming a pattern. यहाँ पे सेम डिजिट या सेम ब्लॉक ऑफ डिजिट रिपीट नहीं कर रहा है, ठीक है, हर बार चेंज हो जा रहा है, एंड इन दिस केस दिस कम्स अंडर irrational. Okay, so now you can identify, and now you are aware with rational and irrational numbers. Okay, now rational numbers, under rational numbers I would like to explain something, that whatever the number system you have studied till yet, except irrational numbers, in rational numbers we have all the number systems like integers. For example, you can see -1, 5, -11. These all can be written, means सबके नीचे में तो means you can write 1, and definitely these are rationals. Okay, so all the integers are rationals, all the whole numbers are rational, all the natural numbers are rational numbers. Okay, so all these number systems, all the numbers lying in these number systems are rational numbers. Okay, so question may be asked in this way, like all the whole numbers are rational numbers, so we'll have to means if the question is based upon true false. Okay, so you have to simply say true or false, but at that time you need to read the state given statements very carefully. Okay, like if what I said, that all the whole numbers are rational numbers, yes, it is true. All the rational numbers are natural numbers, false. Okay, so you can practice, you can form statements by yourself and check. Okay, now let's move ahead. These were just simply explanation of the basic things. In class 10th, in the syllabus of class 10th, first you have to study a theorem which is known as fundamental theorem of arithmetic. Okay, fundamental theorem of arithmetic. Okay, what it says that every composite number, every composite number, वर्ड्स थोड़े इधर उधर हो सकते हैं बट मीनिंग समझोगे. Every composite number can be expressed or written as product of primes. Okay, which is also known as prime factorization. further, and this factorization is unique. वो जो फैक्टराइजेशन होता है किसी एक कंपोजिट नंबर का, वो यूनिक होता है. apart from the order apart from the order in which they occur, means the prime factors. Let us understand with an example, like prime factorization of 6. Prime factorization of 6 is 2 into 3. Okay, that means 6 equals 2 into 3. So in the prime factorization of 6, you will always be getting 2 and 3 only. One number of 2 and one number of 3. Not less than this, not more than this. ये जो यूनिकनेस पार्ट है, ठीक है, इस थ्योरम को हम दो पार्ट में समझते हैं. पहला तो ये that every composite number can be expressed as product of primes. Okay, that means prime factorization. और दूसरा पार्ट ये है कि दिस फैक्टराइजेशन इज यूनिक. ठीक है, यूनिक होता है ना. यूनिक कहने का मतलब ये कि 6 के प्राइम फैक्टराइजेशन में देयर विल बी वन नंबर ऑफ 2 एंड वन नंबर ऑफ 3. ना तो और कोई प्राइम फैक्टर यहाँ पे आने वाला है कभी भी, और ना ही इनमें से कोई 2 और 3 में से कोई जाने वाला है. ठीक है, ना तो 2 का नंबर बढ़ेगा कि 1 से बढ़ के 2 हो गए, 3 हो गए, ठीक है, या गायब हो गया, ऐसा नहीं पॉसिबल है. और ना ही 3 के साथ में ऐसा पॉसिबिलिटी है. ये है यूनिकनेस पार्ट ऑफ दिस थ्योरम, यूनिकनेस पार्ट ऑफ फंडामेंटल थ्योरम ऑफ अरिथमेटिक. लास्ट में क्या है, apart from the order in which they occur. So definitely this can be written as 3 into 2 also. Both are going to give 6. Order change हो गया ना, यहाँ पे 2 हमने पहले लिखा था, यहाँ पे 2 बाद में लिखा है. कोई अगर 6 का प्राइम फैक्टराइजेशन कर रहा है तो हो सकता है वो पहले 2 से डिवाइड करे, या हो सकता है वो 3 से डिवाइड करे. तो ऑर्डर मायने नहीं रखता, ठीक है, कि किस ऑर्डर में आप लिख रहे हो. ओके, सो दिस इज फंडामेंटल थ्योरम ऑफ अरिथमेटिक. ये हो गया. अब आगे बढ़ें. इसके बेसिस पे एक क्वेश्चन बनता है जो कि पूछा जाता है बोर्ड में. क्वेश्चन क्या है, दैट इज इट पॉसिबल, और एक्सप्लेन. अलग अलग तरीके से क्वेश्चन पूछा जा सकता है. मैं ऐसे लिख रहा हूँ, दैट इज इट पॉसिबल फॉर 6 raised to power n where जस्ट अ मिनट, इसको थोड़ा सा मैं चेंज कर रहा हूँ. for 6 raised to power n to end with digit 0. ठीक है, कि 0 के साथ एंड हो, बट यहाँ पे n क्या है, where n is any natural number. n कोई भी नेचुरल नंबर है. ओके, क्या ये पॉसिबल है, ये पूछा जा रहा है. आंसर इज नो, ये पॉसिबल नहीं है. क्यों पॉसिबल नहीं है, तो द रीजन इज फंडामेंटल थ्योरम ऑफ अरिथमेटिक. ओके, लेट्स सी. Okay, so first of all we'll see prime factorization of 6. Okay, prime factorization of 6. So it is 6 equals 2 into 3. So if you're taking 6 raised to power n, means and n क्या है, n is any natural number. So if you're taking 6 raised to power 2, तो ये क्या हो रहा है, जो प्राइम फैक्टराइजेशन है, अगर 6 को उनके प्राइम फैक्टराइजेशन के फॉर्म में लिखें और पावर रखें तो यही बनता है. And what does it mean? It simply means 2 into 2 into 3 into 3. ठीक है, क्या हो रहा है, कोई नया फैक्टर यहाँ पे इंट्रोड्यूस नहीं हो रहा है. डेफिनेटली पावर आने की वजह से जो 6 के फैक्टर्स थे वो पावर के अकॉर्डिंग बढ़ जा रहे हैं, बट कोई भी नया फैक्टर यहाँ पे इंट्रोड्यूस नहीं हो रहा है. नाउ अब यहाँ पे आप देखोगे ध्यान से, टू end with digit 0 कि 0 लास्ट पे मीन्स वंस प्लेस पे 0 मिले, there must be there must be 1 2 and 1 5 in the prime factors. ठीक है, प्राइम फैक्टर्स में कम से कम एक 2 और एक 5 का होना मस्ट है. Then only we will be getting a 0. Why? 2 5s are 10. 2 into 5, 10. The end digit is 0. Until and unless there is 1 2, at least 1 2 and 1 5, you will not get 0 at the end of the number. Okay, so here we'll simply mention, but the prime factors of 6 are 2 and 3 only. Therefore 6 raised to power n will never end with digit 0 for any natural number n. Okay, or for any positive integer n. Okay, here you will have to mention this fundamental theorem of arithmetic. Okay, here only you need to mention by the uniqueness part, by the uniqueness part of the fundamental theorem of arithmetic, we can say, therefore की जगह आप ये लिख दो, we can say 6 raised to power n will never end with digit 0 for any natural number n. Okay, so you can see we have used this theorem to get this result. Okay, or to prove this one. Now let's move ahead. After fundamental theorem of arithmetic, one thing we have proven this. Now in this chapter, the next topic is revisiting irrational numbers. Okay, we will see this in next video. But before this video, we will be going through the first exercise of NCERT. Okay, exercise 1.1 of NCERT. Okay, but this will be also you will get in next video. Okay, so thank you for now. Okay, we'll be meeting soon in our next video. Thank you for you, and you are always welcome for your suggestions and for your comments. Okay, so that I can improve my videos. Okay, bye.